Alright, in this video we are going to do the setup for CAM, getting everything set up the way we need. There will be subsequent videos for creating the toolpaths. Alright, now here where it says design, we're going to drop that down and click manufacture. This brings up all our options for CAM, computer aided manufacture. First, I'm going to click units. I want to change this from millimeters to inch. And let's start by entering our tools. We have about 7 tools that we need to put into our tool library to mill this part. So up here under Manage, I'm going to click on Tool Library. And let's see, we've got this clock. I assume it'll allow me to put them in specific to this clock face. I'm going to click plus. And the first thing it wants to know is what type of tool we want to put in. The first tool we have is a flat end mill, so I'm going to select that. Now under General, it has description vendor. I'm not interested in that. I'm going to go straight to post processor and tell it that this is tool number 3. That is important. When our CNC machine goes to pick the right tool for the job, it knows that this tool is tool number 3. We need it to pick the right one. I'm going to set that as 3. Then I'm going to go to cutter. The number of flutes is 3. However, this is not high-speed steel. It's carbide. The diameter is 3 divided by 8. Shaft diameter is the same. I'm going to leave the overall length. That will be fine for this job. And see, shaft and holder. I'm not going to deal with the different types of holders. And I'm going to go to cutting data. Speed, I want to run this not at 5,000 but at 2,300 RPM. And I want a feed rate not of 40 but of 15 inches per minute. That gets me a feed per tooth of a little over 2/1000 of an inch, which is good. And I'll have a ramp feed rate of 5. And these others should be good also. So let's click accept. All right, there's our first tool set up. 6 more to go. I'm going to click on plus. This next one is a drill, not a spot drill, but a drill. I'm going to go right to post processor. This is tool number 29. And skipping over general, go back to cutter. It has not 4, not 3, 2 flutes. It is high-speed steel. It has a diameter of 5/16, and shaft diameter is the same. Most likely it is 118 degrees on the tip here. That's the angle here. Go to cutting data. I'm going to slow this from 5,000 down to 2,000, and I'm going to give it a vertical feed rate of 10. And click accept. On to our next tool. This is, it's actually called a drill mill. They don't have that, I don't think, unless they've updated this. So let's look for a chamfer mill. Yeah, this engrave or chamfer mill, and we will be using it for engraving. Post processor, the number of this one is 53. And now for the cutter, this is a 2-flute. It is not high-speed steel, it's carbide. The diameter is 1/4 of an inch. The shaft diameter is also 1/4 of an inch. The tip diameter is 0. The taper angle is 45 degrees. Inclusive angle is 90 degrees. The shoulder length and flute length don't matter for what we're doing, so I'll leave them where they are. And we'll go to cutting data. I want this to spin as fast as the machine will allow, which is 5,200 RPM. And we'll have a cutting feed rate of 15. That should be good for this tool, so I'm going to click accept. Number 53 is in there, and let's move on to number 61. 61, the tool is actually called a shear hog, and I'm fairly certain they don't have it. However, we will use a face mill to approximate it. It is 61, and it is practically like this face mill or shell mill, except it only has one of these carbide inserts. So number of flutes is 1. It's not high-speed steel, it's carbide. The diameter is 3/4 of an inch. The shaft diameter is also 3/4 of an inch. The overall length and so on is fine. This flute length I'm not sure of, but make sure you've got something in here that's greater than 1/10 of an inch, because we'll be taking 1/10 of an inch cuts with it. It's probably more like 2/10 of an inch. There is a very small corner radius on that, but we're going to ignore it. Cutting data, we're going to put in 23,000 RPM with a feed rate of 15 inches per minute, meaning that this is taking very large chips that are 6.5 thousandths of an inch thick, which is what this tool is designed to do on this machine. I'm going to click accept, and we can move on to our next tool. Number 64 is a center drill. This right here, the post processor number on this one, 64. All right, to cutter, the center drill has 2 flutes. It is high-speed steel. And this diameter is 3/8 of an inch. That diameter is 3/8 of an inch, and the tip diameter I am not sure of, but it is probably very close to what they have there. And we will leave the rest of this information in here. They put this taper angle on there. The center drill we're using actually isn't that long. but it doesn't matter because we're not going very deep with it. I'm going to click on cutting data for this, and we'll run this at 2000 RPM. And we will put in, for plunge feed rate, 5 inches per minute. Cutting feed rate doesn't really matter. We're not using it for cutting in a horizontal direction. Just going down in the z-axis. Click accept. And we'll move on to our next tool, which is a drill. Going to post processor, it is tool number 70. Going to cutter, it is a 2-flute high-speed steel drill with a diameter of 0.1065 inches. It updated the rest of that. It made this crazy long, but I'm not too concerned about that for now. And I'm going to go to cutting data. I'm going to run this at a full 5,000 RPM, but I'm going to put a plunge rate of 10 inches per minute. And I'm going to click accept. All right, one more tool to go. This is a tap, a right-hand tap. Tap left hand, tap right hand. I'm going to go to post processor. This is tool number 71. Going to go to cutter. This is a 2-flute. It is high-speed steel. It has a diameter of 0.138. Shaft diameter is well enough at that. And the thread pitch is 1/32 of an inch. 32. It's a 632 tap, so 32 threads per inch. So a thread pitch is 1 divided by 32. And it puts that in. Cutting data, I do not want to run this anywhere near 5,000 RPM. I want to run it as slow as our mill will go with that gearing, which is 400 RPM. And click accept. All right, now we have these tools in our tool library under Clockface 2021. So I'm going to click close. Now we're back looking at the clock face. The clock face is made of aluminum, cut out of a piece of aluminum that's about 6 inches by 6 inches by 1/4 of an inch thick. The first thing we do with our clock face is to drill this hole and mill out this pocket in the back. That pocket and hole provide a place for the clockworks to attach and rest, but for milling, this pocket in the back provides a pocket that goes over a fixture, and then a bolt goes through the hole, holding the material tightly to the fixture so that the front can be milled. So we have two different processes, milling the back and then milling the front. So we have two different setups. So the first setup I'm going to call setup 1, and that's milling the back. So I'm going to go to setup and click new setup. All right, the first thing I want to do is get these axes straightened out. So under work coordinate system, I've got model orientation. I'm going to select Z-axis, plane, and Y-axis. And then for Z-axis, I'm going to click on this back surface of the clock face. All right, it has set up the Z-axis the way I want, pointing up out of the material. But the X and Y axes aren't the way I want. So I'm going to click on flip X axis. Now that is all the way I want. This other stuff, machine and setup and whatnot, I'm going to leave as is. I'm going to click on stock. And instead of relative size box, try fixed size box with a width of 6 inches, a depth of 6 inches, and a height of 0.25 inches. And when we're milling, starting on the back, this is our setup. I've got everything in there the way I want it to be. I'm going to click OK. Let me see if I can rename setup 2 setup 1. Huh. Well, I'm not sure. Maybe there's a way to do that. Can't find it quickly. Wish it was saying setup 1 there instead of setup 2. But I'm going to go ahead and get another setup. This it's calling setup 3. And if we flip this over, we have the Z-axis coming up off of this surface. And we have the stock set up from the preceding setup. That is exactly what we want. I'm going to click OK. All right, now we have all the tools loaded, and we have our setups in here, even though they're named 2 and 3 instead of 1 and 2 respectively. I'm going to go ahead and save this, and that concludes this video.